Hey guys, welcome to the Ad Astra podcast, the podcast where we integrate space, policy, and technology. I'm Jack.
And I'm Newton.
I have a Master's of Public Policy degree with a concentration in science and space policy.
And I'm a PhD in computer science and an all-around tech geek.
All right, guys, before I forget, follow us on Twitter at adastra_podcast, like us on Facebook, and subscribe to our mailing list on elemental.fm to get regular updates from the team. If you like what you hear, review us on iTunes and recommend us on Overcast.
Okay, and today we are going to run through, in our latest in Washington section, we'll be talking about the president rolling back some of the environmental protections of the last administration. We have two space news highlights in store for you. We'll get to those a little bit later. International updates, where we'll talk about China's space program and what they have in store for us at the 33rd Space Symposium. The latest in tech, where we'll discuss the PACE satellite and major milestones being met with that satellite's development plan. Our listener submitted queries section, where we get to answer one question by one of our listeners posted to Facebook, Twitter, or any of the other social media that Jack previously mentioned, and coming soon to space, where we'll get a little bit more into the 33rd Space Symposium.
All right, so we're starting off with Washington. So I think everyone who's listening, or if you're paying any attention to politics, has seen that the administration is rolling back on the Obama-era climate change regulations. An executive order was signed this last week at the EPA, where President Trump took away some climate change regulations, specifically dealing with coal and fossil fuels. So, Newton, do you want to? I know you're antsy to talk about this.
So there were several key presidential actions from the Obama administration days that were revoked by this executive order. The preparing the United States for the impacts of climate change executive order, power sector carbon pollution standards, which basically defined boundaries for how much carbon can be emitted from the power sector, so coal and gas plants, mitigating impacts on natural resources from development and encouraging related private investment. Presidential memorandum that was pushed out in November 2015, as well as the climate change and national security presidential memorandum. This executive order basically repealed each one of these previous presidential actions and requires of major government agencies that within 45 days of the date of this order, that the head of each of those agencies submit a plan to carry out a review to make sure that each agency is abiding to their obligations for this order, and then within 120 days to submit a draft final report, and then a final report within 180 days to adhere to the regulations of this order. One thing that this measure does not address is whether the U.S. will remain in the Paris Agreement on climate change, and the White House officially said Monday that the global climate deal remains under discussion. And just for reference, the Paris Agreement gets a number of world governments to agree to a long-term goal of keeping the increase in global average temperature to well below 2 degrees Celsius, but above pre-industrial levels, to aim to limit the increase to 1.5 degrees Celsius, since this would significantly reduce risks and the impacts of climate change. The need for global emissions to peak as soon as possible, recognizing that this will take longer for developing countries. Clearly, they barely have, many countries in South Asia and in Africa barely have infrastructure set up. So it helps to enable them to build their infrastructure in a way that in a way that helps that country, each of those countries progress, but keeping this climate change goal in mind as well. And finally, the Paris Agreement gets each of those governments to undertake rapid reductions thereafter in accordance with the best available science. So just to be able to take on new technologies as they come, to agree to take on new technologies as they come, in order to battle climate change. And basically, the administration, Jack, just told them, "We'll see," when it comes to that, and really didn't mention that in this executive order, which I think we all saw that coming from previous talk of the administration.
Yeah, this isn't something new. I mean, with there only being 24 hours in the day, there's only so many uh, regulations they can repeal and executive orders they can release. Um, it's disconcerting to see this happening at a time where just after the Paris Agreement has been decided on, and Russia and China, these major nations are willing to sign on or discuss signing on to the agreement, that the U.S., although not the world's largest producer of greenhouse gases, it is in the top three. Um, that it is pulling out, or most likely going to be pulling out, and also on the domestic front, rolling back regulations that really I just don't see, other than by pure, just because it has Obama's name on it. It seems that they're repealing these, and that most of the administration has money in these fossil fuel companies, because it's. I mean, I remember seeing there was a press release from, I think it was ExxonMobil, and they were saying, it pulling out of the Paris Agreement would be a bad idea. And I think we've talked about this before, both on the air and separately, that there are so many of these companies that are starting to comply with the terms of these agreements and regulations already, that it makes almost no sense for them to roll back. They've already spent the money on meeting these new regulations, or attempting to meet these new regulations.
Right.
Why? And that's also the direction of the market. Like, why would they then turn and say, "Oh, well, since the president rolled back on these, we're going to basically erase the last 8 years of work that we've done on becoming compliant with these regulations." And I mean, it just makes better business sense too, because that's the direction of the market, right?
Right.
Like, it's worldwide, regardless of whatever the United States government does. There are governments worldwide that are uh, requiring similar or even stricter regulations. I can think in Europe, they're much stricter over there. China's starting to crack down on polluting and environmental regulation. So it makes no sense for these multinational or these international companies to be, "Oh, well, the U.S. isn't doing it, so I don't have to do it elsewhere." They're going to comply with the Paris Agreement regardless. It's the U.S. government then that's going to be behind the curve on
Right.
this.
I mean, this is the problem that you run into when it comes to quite frankly, isolationism. Is you have the rest of the world buying, and you're going to have the rest of the world having an entire economy made up of clean energy technologies that aren't necessarily being used to the extent here that they are over there. It literally puts us behind in one of the great economies of the world for the next century. Which, yeah, this is it. If I would love to see what the strategy here is, if there is one. Quite frankly.
I really don't think there is. I mean, I think it's, let's repeal these executive orders, these regulations, for the sake of looking good politically. I mean, it makes perfect sense that the administration is doing this just at the same time that they're still campaigning whether it's for 2016 still, 2018, or 2020, it's unclear. I mean, the
Right.
president is out it seems almost 95% of this time. It's not actually 95% of the time. I'm sure he goes to work sometimes. At least he goes to Mar-a-Lago enough to make it seem like he needs a break. But it seems like every time that I hear him speak, half the time it's at a campaign rally and the other half of the time is as
Right.
president. So it's almost as if, his personal ambitions are interfering with his professional ambitions.
That's just crazy talk.
Yeah.
But,
It couldn't be. It couldn't be. We don't live in the world of alternative facts.
No. But so the day after this executive order was released by the White House, the House Committee on Science, Space, and Technology held a hearing.
Alternative science.
On alternative science. So, are we just going to have it like that for the next 4 years?
If we keep Lamar Smith in there.
Yeah. So the House Committee on Science, Space, and Technology held a hearing called Climate Science Assumptions, Policy Implications, and the Scientific Method, which we will get to. Strap in, ladies and gentlemen. Four witnesses were asked to testify before the committee on March 29th. Dr. Judith Curry, the president of Climate Forecast Applications Network, and a professor emeritus at Georgia Institute of Technology. Great school for computer science, by the way, ladies and gentlemen. Dr. John Christie, the professor and director of Earth Systems Science Center at the University of Alabama at Huntsville. Dr. Roger Pielk Jr., a professor of at the Environmental Studies Department of University of Colorado. And Dr. Michael Mann, a distinguished professor of atmospheric science at Penn State. Michael Mann actually ended up with getting the most press for speaking at this meeting, at this hearing, because he was speaking the most assuredly and seemingly defending climate change as a real man-made threat that we must mitigate. And it's safe to say that he came out looking as if he was the only person who stood for science. Now, in fairness to the other three witnesses that were at this committee hearing, they testified. They simply testified that we don't really know how much people are contributing to climate change, and there's too much uncertainty to consider global warming a threat, which is mind-boggling.
They found the three people. When people
Right.
say there's 97% of scientists agree,
Right.
the remaining 3%, they found them because there's only 100 scientists.
And
But-
and this hearing was just full of ridiculous questions just throughout the hearing, or questions that you've just heard the answers to 100 times before. Representative Mo Brooks from Alabama asked the witnesses whether it's true that sea levels are actually going to fall, not rise, as a result of global warming, when we have measurements showing sea levels rise and the rate at which they're rising. Representative Daniel Webster asked whether we know that the ice ages was caused by climate change, just to make the point that the ice ages occurred naturally, and so we can't claim with certainty that climate change is human made. There was just all of this manipulation of of public view of science within this meeting.
And remember, this is all public record now too.
Right.
Like this has all been recorded. I mean, in the show notes for this episode, we'll include a link just directly to the video of the committee hearing, and you can hear for yourself just how absolutely ridiculous it is. The one thing that really stuck with me was between Dr. Mann and Lamar Smith. Mm-hmm. Where Dr. Mann was citing the journal Science, which is a reputable source. I mean, if you talk to any scientist, I mean, really anybody in academia has heard of the journal Science.
Yeah, it's a go-to for citing for citing papers, and it's great if you can get one of your papers in there.
Yeah, like, I mean, you get to say that you wrote for science. Like, this is an actual paper. And Lamar Smith, Texas, right?
Uh,
I
Texas, I
think.
believe, yes.
I think. Sounds about right. But so he goes that he says that the journal Science is not objective. That it isn't. The quote here, after
I
a little bit
remember
of
that
debate.
now. I blacked out when he said that at one point, but thanks for bringing that back up. Go on.
So Dr. Mann was talking about some research that he was reading, quoting someone in Science, and Lamar Smith asked who said that, and Dr. Mann, that's in the journal Science, and Jeffrey Mervis was the name of the author of the article, and Lamar Smith says that is not known as an objective writer or magazine. So demotes it from journal to magazine, and then also completely just pushes aside, okay, this Jeffrey Mervis guy, like, he could have as many PhDs or doctorates in the world, and Lamar Smith is not going to take his word on anything now.
Oh, yeah.
And this is public record.
So Suzanne Bonamici, I'm butchering her name. Sorry, Suzanne. Representative Suzanne Bonamici of Oregon. She was quoted with, just kind of relaying that famous point that the witness panel does not really represent the vast majority of climate scientists who have concluded that there is a connection between human activity and climate. For a balanced panel, she said, we need about 96 more Dr. Michael Manns, just to just to fully represent the U.S. population. And what the point that she's trying to relay there is that there is a consensus that humans are causing global warming. It is the position of the academies of science of over 80 countries, plus many scientific organizations that study climate science, and specifically around 97% of active climate researchers actively publishing climate papers endorse that consensus position. And if you want any more on that, since this is a space podcast, you can go to climate.nasa.gov/evidence. There's plenty more plenty more to look up there.
Long as that website exists.
So look it up
after
now.
This.
Well, Google has it cached, so they can't
can't get rid of it forever.
They cannot get rid of it. Thank you web crawlers.
That's what they say. That's what they mean when they say if it's on the internet, it's on there forever.
Yes. It really means Google
you can delete it, but it's in a cache somewhere. Someone has it somewhere.
Right. So one of the things that it's interesting, because now these folks are, you were talking about this earlier, that Trump is going on crazy rallies, and actually a lot of the congressmen are getting ready to go home for Easter, for some version of Easter break or Passover,
recess,
it's just their spring recess basically, and they're going to be going home and campaigning. And as some recent polling data shows, their stances, at least the folks in the House who are pushing sort of this anti-climate change or climate skeptic stance, those stances may not hold up in front of their town halls. On March 21st, polling data was released about climate change beliefs in the U.S. The Yale program on climate communication conducted a survey on public opinion of climate change. Americans overwhelmingly believe that global warming is happening, apparently. And shocker.
69%, right? Is the number that they gave?
Yeah, it's 69%. So nearing 70. And it's not only that they believe it was happening, which I think most people recognize at this point, but that carbon emissions should also be scaled back. Much fewer believe that it will harm them personally, but nationally, roughly 7 in 10 Americans actually support regulating carbon pollution from things like coal-fired power plants, and 75% support regulating CO2 as a pollutant more generally, which is quite surprising.
Yeah.
Um,
So for all of our listeners, if in the show notes there was a New York Times article
mhm,
that has this polling data and some really cool maps that they put together. So follow along. It's about a third of the way down the page.
right,
But yeah, I mean, like looking at these maps, the one that I'm struck most by though is the one that the lead quote above it is, most people think that climate change will harm Americans, but they don't think it will happen to them.
right,
And you can see this stark contrast where on the left you have a map of the United States where, I mean, I would say close to 70% of the people. I mean, obviously there's some blue which indicates less than 50% of the people think that global warming will harm people in the United States. So less than 50% in a lot of the central areas of the country. But when you look at those really deep oranges and red counties, I mean, these are high population centers. I mean, California is almost entirely, blood orange. But I mean, it very much looks like there's a lot of people who believe that climate change will harm someone in the United States. It doesn't, obviously doesn't say how or by what means, but it shows that a lot of people believe this. But on the right, you see a map that's almost entirely, it's this turquoise color. It's a seafoam turquoisey color, which indicates close to, just maybe somewhere between 20 and 40% of people don't think that climate change will affect them personally.
right,
And I'm looking at all of these really deep blue turquoisey counties that are right on the coast. And I can tell them for certain that climate change is going to affect them personally. I mean, we've already seen it with Superstorm Sandy. I mean, we've seen it basically every year with the big hurricanes that hit the eastern United States. But we're seeing that with flooding and drought in the western United States. With the drought in California still not necessarily over.
right.
I remember there was a few articles saying that it is officially over, but I mean the repercussions from it are California and the western United States are still reeling from a lot of that, and this is a direct impact of climate change. People might only think of climate change as rising sea levels, which are extremely dangerous and are hurting a lot of people. A majority of the country lives on the coast, and it'll be hurting them even more in the future. But these subsequent problems that climate change creates, so drought, famine, all of these things, consolidate and pile up and make the situation worse for a lot of people in a lot of parts of the country. It doesn't really matter if you're in Colorado, California, or Connecticut, you're going to get impacted by climate change.
Right. And one thing that honestly bothers me when I even see results like this, though, because mind you, this is being reported in a positive light that people finally believe this, these that climate change is happening, that 70% of people finally believe these things are happening. It's really strange to me to use the term belief in a scenario in which we are continuously observing that in an objective standpoint that something is happening, and are simply reporting, creating models that are predictable, in order to report what can happen to us in the future, and have those models validated over a long period of time using more observations, and still get nothing, and still get people kind of opting to believe whether or not this thing is happening. And I know you've had your share of discussions with climate skeptics, and I'm not just going to sit here
I don't
and
know if I'd
rail.
call them discussions.
Well, I mean, the thing is, when discussing global warming, a lot of times climate skeptics will say, "Oh, it's just a theory, or here's this study that disproves your claim, and therefore climate change, climate change can't be real. Or I've even heard personally that, oh, we can predict the weather we can't predict the weather next week, and I'm supposed to believe we'll know what it'll be like in 100 years. And typically, and this may be just a messaging issue on the what I hate to call the other side of this issue. But snarky people usually reply by asking climate skeptics, oh, you don't believe in that theory, or those models? Do you believe in evolution or gravity? Or they'll go ahead and cite the whole 97% of scientists believe in this claim, which, once again, using that term beliefs still kind of irks me. In reality, climate change is a reality not even because of the whole 97% of scientists issue. It's a reality because experimentation and refined models have exposed it as reality. Now, we can have semantic arguments all day about how the word belief applies to reality. Nonetheless, this argument is a problem with a lack of understanding about what a model is and the way a model works. I think there's a significant gap in terms of potentially in public education for
Oh,
understanding
yeah.
how models relate to reality. Okay, science works by building models, not little plastic models and toys that you construct, but models that are comprised of mathematical symbols and operators. And and these models are used to describe reality. We feed these models inputs from real world observations, like, for instance, air quality from Earth Science's remote sensing satellites that are being produced by NASA.
Got to
And
bring space into here
yeah,
in here a
exactly.
little bit.
Just remember, it's a space podcast. And those models are able to, over time, pop out a correct answer about how the world works. If you want a better example, let's step away from climate change and maybe towards a little bit of space science. If I drop this pencil, I'm holding a pencil, ladies and gentlemen, it'll accelerate towards the Earth at roughly 9.8 meters per second squared. I don't just know that because I did it a bunch of times and measured how fast it was and just went, yeah, that seems about right. I know that because we have a rough idea of the mass of the Earth and the mass of this pen, and the model for planetary gravity mathematically relates those two masses and can reliably tell me how quickly that pencil will drop. So I can know it before even dropping it. And that's just a simple example. In science, there's often not absolute certainty. Okay, that was a very simple example. There's not that kind of certainty in much of research, right? Research, which comprises experimentation using models and corrections of those models based on observations, reduces that uncertainty. In many cases, theories have been tested and analyzed and examined so thoroughly that their chance of being wrong is extremely small. And when they become infinitesimally small, it leaves engineers and practitioners room to create and operate based on those models. For instance, as another example, take Einstein's model for general relativity. Our satellite systems leverage this model to account for gravity's impact on a satellite's timing mechanisms, which have to be in sync for communication. I don't want to get too into the weeds because we are coming up against the clock here. But the theory says gravity curves space and time. It's mathematics. Its model requires that objects traveling at different speeds have their own separate clocks or sense of time, and it works really well when it comes to that sort of thing. But there are other times when uncertainties linger despite lengthy research. Those uncertainties are typically derived from observations of edge cases in which a model can't describe a particular physical phenomena. One example is use of the classical physical model of gravity at the quantum scale. That requires a different model for describing physical phenomena based on the wave-like nature of matter. In such cases, scientists can have a really hard time because now it's their job to explain how well something is known. When gaps in knowledge exist, scientists qualify the evidence to ensure others don't form conclusions that go beyond what is known. So it's not that we don't have a confident way to describe gravity. We just have to qualify it by saying this model works at this scale and this model works at this scale. So new discoveries can sometimes be made that seem to refute a prediction made by a model like gravity or climate change, but it doesn't necessarily mean that the entire theory is wrong.
I mean, and in a lot of cases, that can even sprout a like a whole new branch of science.
Right.
Right.
Absolutely.
I mean, like the whole idea of quantum physics came about when the the theories of general relativity and gravity didn't work on that scale. And I mean, when you're looking at something on the cosmic scale, the galactic scale, something as galaxies, moving away from each other, but then Andromeda is still heading towards us. Like I probably can't talk too much in the science here, but I mean, I've gone through enough talks and talks about dark matter and dark energy that sometimes there's just not an answer to a question.
Right, but it doesn't mean that what you've already discovered and the models that you've created based on what you've discovered are wrong. There are just other questions. There are just new questions to be answered, which is why we are continuing to do research, right? And now that we're pulling in all of this information and it's completely exposed, the public is now able to digest all of this, is now able to pull in this information at will and use it to refute effectively. I hate saying this, they use it to refute models that they really don't have they really don't have a lot of insight into how the model is structured, how they're created, how it works.
Or even just how the scientific process works.
Right.
I mean, what I'm seeing here is that this is a illiteracy problem.
Yeah, it's a scientific illiteracy. No,
yeah, scientific illiteracy. Like that's what this is people thinking, I guess, wholeheartedly believing that something like science can be just as malleable to opinion as politics is, or how your opinion of a movie is, like that everything is an opinion, and that every opinion is validated solely because it's an opinion. When it comes to the scientific method and science, there's
go ahead.
Yeah, validity isn't inherent. And even outside of that, in politics, in movies, I mean, like across the board, like not all opinions have an inherent validity. I mean, you can have an opinion on anything that you want. I mean, First Amendment all day. But to assume that because you're saying something or because you're referencing an article does not inherently mean that you have total and complete validity. Now, what a lot of those articles that they cite talk about, the climate denial articles that they point to, even some of those recognize that climate change is happening, just not maybe at the same rate that other scientists are reporting it as.
And they're heavily caveated. They're heavily caveated within journals in which they're published, in which they're published. Otherwise, they would not be able to be published within that journal. There is no valid journal that full stop has an article that says full stop that climate change is not happening. Okay, there's no valid journal with updated.
I hear
with
Fox
any
News
updated science.
Fox News is coming out with a journal next month.
Oh, okay. Then that might be the case.
Breitbart journal.
I'm pretty sure Breitbart already has one.
But I mean, you're right. You're right that there's that. I mean, a lot of these articles have caveats, and the scientific consensus is there. The science is real.
Right.
I mean, like you could say you believe in, I don't know, aliens. That doesn't necessarily mean that like they're going to come land in your backyard.
Right.
Like it's you're putting yourself in this tunnel.
And the problem is those kinds of studies just they tend to raise doubt within the public, and a lot of that happens from bad science journalism in many cases, in which someone takes the article from a peer-reviewed journal and tries to summarize it. And in some cases, now that you're bringing up Breitbart or Fox News, they will summarize it they will take the results and report on it to the public in a way that promotes their political standpoint.
So what you're saying is that this whole problem that we're having with climate change denial is just the result of a really bad game of telephone.
Yeah, I mean, that's a big, it's a bit more than that, but I mean, yeah. But let me try to wrap this up. So quite frankly, folks, we've discovered a great deal about climate change. I'm just going to say it definitively on here. We've learned, for example, that burning of fossil fuels and the clearing of forests release carbon dioxide into the atmosphere. There's very little uncertainty about this, okay? We have learned that carbon dioxide and other greenhouse gases in the atmosphere trap heat through the greenhouse effect. Again, very little uncertainty. Earth is warming because these gases are being released faster than they can be absorbed by natural processes, and climate models have demonstrated that human activities are very likely the main reason for the world's temperature increase in the past 50 years. I can link you to studies for each of these things. But let me be clear. Experimentation and modeling has revealed the following to the world, okay? Human-induced warming influences physical and biological systems throughout the world. Sea levels are rising. Glaciers and permafrost are shrinking. I mean, good God, we have actual images in the visual spectrum taken over time for that. Oceans are becoming more acidic. We're actually measuring that. And ranges of plants and animals are shifting. There are doubts about certain things. And experimentation and modeling have to continue to be done. That's just research. And those things will reveal information such as how much global warming will occur in the future. Will it be a 2.1 or a 4.2 degree shift by the year 2100, right? How soon the summer sea ice habitat of a large number of animals will disappear. Okay, those things are a bit uncertain. We are continuing to research. Those things, but we've refined models to demonstrate that those prior dangerous things are happening. And this is why choices we make in the next decade or so to reduce emissions of heat trapping gases could prevent catastrophic climate change. The models are reliable. Let's do something about it. Moving on.
Science is real.
Science is real.
That's great. I mean, just anthropogenic climate change is real.
Yes.
It's happening. We have to deal with it. I mean, I almost think of it as, we're standing on the shore of the new world, mm-hmm. of where we just kind of are getting a grasp of just how big this issue is starting to be. And the climate change denialists are saying, oh, well, we could just turn back and go back to our old ways, go back to the old world and just not worry about it, when there's this whole new world of scientific discovery and exploration and development that could be done by investing in climate change research. I mean, we are on the cusp of developing technologies that will literally save the world. And if we don't do anything now, I'm not sure we're going to have, great-grandchildren or great-great-grandchildren who will be able to do anything themselves, not from a lack of desire to do something, but from a lack of resources and capabilities because we stunted their growth.
Right. And real talk for a second. I just paid my taxes today and then had to listen to those taxes being spent on a House Science Committee hearing on whether or not consensus science is actual reality. What's that?
Most of your taxes went to the DoD.
Okay, that's fair. That's fair. That's a whole other show.
So let's into the space news highlights. We talked a bit on climate change. We're almost at about 40 minutes now.
A little bit.
So we have two space news highlights, one of the week and one of the decade.
You decide.
Yeah. Well, I listeners, in the next 5 seconds, please guess what the, the space news highlight of the decade is.
Okay. All right. So
SpaceX.
SpaceX.
So obviously that is the big news. They had their, I don't know if we can call it a Kitty Hawk moment quite yet, but SpaceX launched last Thursday at 6:29. Was it something, or 6:39 p.m.?
It was around 6:30.
Around 6:30. It was, the videos are online.
Yeah.
You can find them now. You don't need to know the time. But launched an SES-10 satellite to geostationary orbit. So this is a really, really high orbit. But they launched on a flight-proven Falcon 9 booster, which is, I mean, has really never been done before for orbital launches. Blue Origin, of course, has been doing this for a couple of years now on suborbital trajectories. But SpaceX is the first time. I mean, this is them proving that reusability can happen. And not only that, but they also recovered the second stage fairing.
Yeah.
Which is also big, because that itself, that little bit of metal that connects the second stage to the actual payload, that's about $6 million right there. And if they're able to recycle that, that's some serious savings. I mean, a rocket launch today costs somewhere in the mid $70 million, depending on your mission assurance that you have on that, and who your provider is. But I mean, $6 million goes a long way in savings.
Right. And, one of my I don't know how you reacted to watching the video. Did you get to watch it live, Jack?
I watched it live. I was at the front page in DuPont.
Okay. I got to watch it after. I had to watch it after the fact. I was leaving work super late. And my one reaction after, seeing this grand moment in history, because this really is a great moment. I don't know. Maybe I expected more celebration out of it from Musk. He was just kind of sitting there in the operations room, and he just kind of talked about it. Like I expected more of a Tony Stark moment from him. I don't know. It just seemed...
Well, you expected him to come out and say he's Iron Man?
Yeah, well, a little bit.
Spoilers. Sorry.
Or stand in front of the rocket with his arms wide open. Just go. Creation.
It would have been hilarious so when we were watching it live, me and a couple friends, we had it up on my phone, and the video cut out. Their video feed cut out from the drone ship as it was coming down. Like, we saw it coming down, and then some dust got into the camera lens, and you couldn't see anything. So then they cut to the drone ship, and then you didn't even see the rocket begin to land before the video feed cut off there. And then just suddenly this huge amount of people in the background of the video erupted in applause. And then it cut to the Falcon 9 standing upright on the, of course, I Still Love You drone ship. And it would have... I was kind of half expecting Elon Musk to be on the launch pad,
right,
with the rocket. Be like, I know it's a drone ship, but I piloted it here. I stowed away.
I know. I expect more celebration from you next time, Elon Musk. That's my comment. But
when Falcon Heavy launches in late summer, he'll be there for that.
I was just about to bring that up. So he tweeted out on March 31st, which was this past Friday, that they're considering trying to bring the upper stage back on Falcon Heavy demo flight for full reusability. He said the odds of success are low, but it may be worth a shot. Look at him caveating that statement.
Yeah, he's like, it very well could be like a 0.5% chance of success, and he'd still tweet that out. But he had to throw in that caveat of, it
might not work.
Very, very unlikely.
It's just funny hearing that from him.
I'm very skeptical.
Yeah.
I mean, I'm sitting here, Newton, you can see I'm drinking out of my Occupy Mars mug, my color-changing mug that SpaceX so graciously gave me. But I'm skeptical as to how much Falcon Heavy is going to be reusable. But I mean, they did this. Falcon 9 is...
Do you mean in the long run?
Well, I think in the long run, I mean, it
Yeah.
seems like SpaceX can do anything right now, which might be part of the hype of Falcon Heavy is and what might be driving Musk to say, oh, we're going to try and recover the second stage. We very well might not.
Right.
You know, it like there's a very solid chance. I mean, the first Falcon 1 and the first couple Falcon 9 did not perform very well. I mean, Falcon Heavy would have to break a trend of poor performance on first launches for SpaceX.
Well, go ahead.
But with this Falcon 9 success, the difference between now and then is not just 15 years, but it's hundreds of, I'd wager to say thousands of hours of experience that those engineers and flight technicians and mechanics and everything now have that they didn't have 10, 15 years ago. SpaceX now has a dedicated, not only just a dedicated fan base, but a dedicated staff of people with these immense skill sets that's at this point seem like they can do anything. I'm saying my perspective is let's be careful about saying, we can do anything, because the last time, we had this sort of moment where, we can do anything. We went to the moon. Didn't follow that up very well.
Right.
But I'm extremely excited about the prospects that SpaceX has, and I do have full faith and confidence in them. I just want to throw that caveat in there that they haven't had successful first flights.
I agree with that. However, their unsuccessful first flights were trying to do this. It's this activity that had never really been done before. In effect, Falcon Heavy is the Falcon 9 is a rocket with I believe 3 Falcon 9 core engines in it. So it's effectively a massive Falcon 9. So their issue here isn't necessarily the angling and precise velocities that are required to get the rocket to land, well, and obviously the chemical makeup as well, to get the rocket to go up and then land. It's really dealing with the massive. It's really dealing with the Falcon 9 problem, but at a much larger scale. So I won't say it's going to be easy for them to do, and I certainly won't say that they're guaranteed to do it on the first try. But I actually think there's a reasonable probability that if they were to put the effort into it to do it on the first try, that they could get away with doing it.
Absolutely. I mean, I think SpaceX is entering a new era where the last 15 years has been building up to this moment on the drone ship of re-landing at a flight-proven first stage.
Right.
I think that they've made the business case now,
Yeah.
and they're going to continue to make that business case. I think they're eyeing 6 more launches, or 6 total launches. I'm not sure. I think we're still at least 5 more away
for this year.
For this year, They want to do 5 to 6 more Falcon 9 flight-proven launches and re-land them.
Okay.
Now, what the timetable is on that is still uncertain. A lot of those payloads we're still sort of waiting to hear when they'll be ready. But I mean, I think SpaceX can do it, and now they're in the black, right? They've made the business case. The cost is probably already starting to go down. I mean, I was looking at SpaceX doesn't have stock yet, but Tesla does, and Tesla's stock is going up. Surprisingly, as Boeing and Lockheed's are going down. But like SpaceX and Elon Musk have proven themselves. And I think really They can only go up and then back down from here.
I see what you did there.
Space pun.
Space pun. All right.
So let's talk about the space news highlight of the week. Now, that previous one was the decade, obviously.
This might turn out to be of the century, though, eventually, in my opinion.
Or at least space news highlight of the space age.
Yes, potentially. So on March 28th, NASA released an article regarding and made an announcement regarding its deep space gateway and deep space transport. So effectively, the first phase of exploration near the moon will use current technologies and allow us to gain experience with extended operations farther from Earth than previously completed. NASA is planning on placing a large-scale space apparatus in cislunar orbit around the moon. What NASA is calling a deep space gateway is at first meant to just be a platform for testing new and emerging technologies for deep space missions. But its overall goal it will be to later serve as the base of operations for deep space missions to Mars and beyond, as well as both manned and unmanned excursions to the lunar surface. So just hopping on and off the moon is casually as they please,
as astronauts will to do.
Yeah. So this one's really interesting. The notion of within and we'll in our show links we'll put NASA's intended schedule and plan for doing the Deep Space Gateway, but in roughly the 2020s they're actually talking about having this effectively a space station sit in cislunar orbit, orbiting the moon, allowing us to conduct operations a bit further out into space than we normally conduct operation, and effectively giving us a base from which we can do experimentations that are a little bit outside of they're outside of Earth's low Earth orbit, and I'm here for it. I think I think it's a good idea. I don't want this to dive back into our previous discussions about Moon versus Mars, but I think that they're taking the appropriate path here in that we're not setting up a base on the moon. We're setting up effectively an outpost from which we can do experiments, conduct operations, and use as, to some extent, an initial relay station for our further journey to Mars.
Yeah, I mean, I might have to retract some statements I said about the moon.
well, here's what it is. The way that it was proposed to you initially was not great, and then
that's
NASA
true. NASA
got their hands on the idea.
Yeah, well,
and then they made it great.
I think. Like the Deep Space Gateway, I'm with you on this, that like this actually might be the most exciting thing to happen in the last week. I mean, SpaceX, that's impressive. This might be the most interesting because this answers those questions about Moon versus Mars. I mean, if anyone's ever seen the squid chart, which we should try and find a link to that, was this chart, the journey to Mars. I'm sure everyone has seen it in some capacity or another.
We'll post a link. We'll put the link.
Yeah, if you haven't seen it. But basically it was this, we call it the squid diagram because it has these like tentacles going from Earth to Mars. And there were different iterations of it that called, there was Earth-dependent systems, inner or like proving ground, and then Earth-independent systems. And then there was like the moon was kind of there, and then an asteroid was there, and then Deimos and Phobos, the moons of Mars, were kind of there, and it was kind of unclear what the whole purpose was, and never really gave too much information. I mean, that was the journey to Mars. I mean, when people talked about the architecture for the journey to Mars, they pointed to that poster and said, that's about as far as NASA's gotten. The Deep Space Gateway, is the next iteration, but it's complete with everything, it almost feels like. So in the show notes, we'll also include some links to some photos that our friend Jeff Foust over at Space News talked about.
Yeah, there's some
was tweeting
interesting
about.
photos about like a proposed setup for that relates to international cooperation and things like that regarding who will control the habitat module, the airlock module, things like that. And these are just proposals. This thing was just announced. Who knows what who will actually be who will actually be in charge of which component of this thing. But what's interesting here is last week we were just talking about the International Space Station and what could be done with the International Space Station. And at this point, giving figuring out a way to hand it off to commercial entities doesn't seem so bad now, does it, Jack?
Exactly. No, I mean,
Yeah,
and with this on the horizon, with the two photos that Jeff tweeted out, sort of detail the EM missions, the exploration mission. I think it was EM stands for.
Yeah.
EM1 is the one everyone's been talking about because it might be crewed, it might not. I think in July or so we're going to hear NASA's report on potentially crewing the first launch of the SLS Orion combo in the early, or geez, that might even be 2018, 2019, late 2018. But I mean, like we have EM1 and starting with EM2 in the early 2020s, I mean, we're going to start putting people on American rockets back up in space, but also sending out the components to build the Deep Space Gateway. Yeah. I mean, obviously, they haven't gone through the phases of designing and developing all this, which a lot of that is coming from the Next Step program, which we've been talking about the last couple of weeks. Interesting to see this development happen as we're talking about it. That Next Step is it was 6 contractors, or NASA gave money to 6 contractors to develop sort of blueprints for what what we now know as the Deep Space Gateway could look like. And according to some information, also from Jeff Foust, we're gonna have to give him a shout out again, talking about how I think this was from William Gerstenmaier, who is the associate administrator at NASA right now, or the acting associate administrator. If I'm wrong, we'll correct it in the show notes. Talking about how we're not going to down select out of the Next Step program. We're not only going to pick one, but we're going to create a sort of piecemeal project, take the best elements of all of them and kind of put them together, make sure everything works, and develop some sort of, big, a BFC, a big blanking contract for the Deep Space Gateway, and developing these components and starting in the early 2020s, start building it. I mean, this is the vehicle that's going to get us to Mars. I mean, in the second photo.
Well, the Gateway is not the vehicle. The Deep Space Transport, however, may be the vehicle that gets us to Mars. And this was the second big part of this announcement, stating that NASA stated that for those destinations farther into the solar system, including Mars, NASA envisioned a deep space transport spacecraft that combines both electrical and chemical propulsion and would be specifically designed for crewed missions to destinations from Mars and beyond. So that's what NASA's hoping to do, and they would be able to send this transport both to the Gateway as well as, and it would be able to communicate with the Gateway as well as, sending astronauts all the way out to Mars. Think of, the possibilities here, the CONOPS, as they say, the concept of operations, for missions using the combined resources of the Gateway and the transport really does make a Mars mission much more feasible. This is exciting.
Yeah, I mean, I'm looking at the chart that NASA sent out, which is in the show notes, of course. But the deep space transport looks about 1.5 to 2 times as big as the Deep Space Gateway, which is not this is not on the scale of the ISS. Granted, the ISS is a $100 billion space station.
It's about a football field across. I believe.
Football field across, and I mean it's taken 30 years to build it.
Yeah. That was our
This is
first
something
try.
that this is something that in the next decade we're going to have in space. I mean, 2027, the EM6 and EM7 launches of the SLS are supposedly launching the deep space transport. So in 10 years, we're going to have the capabilities to go back to the moon and go back to Mars. And sort of to tie back to our conversation last week on Moon versus Mars, this gives us the capabilities, the modular design of both the Deep Space Gateway and the Deep Space Transport, or at least the proposed modular design and architecture of these missions, would make it incredibly easy if money found its way into NASA to develop a lunar mission, or if ESA wanted to put something on there. One of the things that the Popular Mechanics article talks about is how the airlock will be an international item added onto the Deep Space Gateway. So, I mean, this could be, something that ESA or JAXA or Roscosmos want to get involved and build a lunar lander. I mean, this Deep Space Gateway is going to be the catalyst for things like that. It's a gateway. I love that terminology that they use, that they call it a gateway, because it really is a gateway to back to the moon and to the rest of the solar system.
I mean, I hate to say it because I know technically, well, the SpaceX had a bigger technical accomplishment this week. NASA got me freaking excited this week with this. Like,
yeah,
this is this is what you want. Like, this is what NASA should be. Like, this is the NASA announcement that people were pining for, and I think they nailed it.
People who aren't Excite listeners, if you don't know anything about the Deep Space Gateway, take it from us. This is the big thing this week. I mean, this is the big thing for the next. I mean, I'm sure we're going to be talking about this nonstop for the next 10 years.
Yeah. Well,
I mean, this is.
We were joking earlier offline about the podcast that this may turn out to be the space news highlight of the space age. So this is,
absolutely
it's big. But we've got to get moving on to international updates. Jack, what do you got for us in international updates?
So I don't have much in the way of international updates other than China. The space program administrator for China, Yulong Tian, I hope I'm pronouncing that right, announced at the 33rd Space Symposium it was an interesting panel. There were so many officials from the World Space Agencies there that the stage was so crowded they had to do 2 rows of speakers. And like these are really important people, but there were so many of them that they had 2 rows of speakers. But Yulong Tian was saying that the Chinese space station and a lot of their space platforms and assets will be ready by 2020. So, I mean, as the ISS sort of starts, either transitioning over to commercial entities or being decommissioned, we're already seeing China taking the lead on finding a replacement for a low Earth orbit station. And I'm sure we will hear a lot more from ESA, whether they're partnering with the U.S. to maintain ISS, or if they're going to be going to the Chinese space station, or if they have their own plans. They could very well have their own plans. But I mean, this is internationally, not much has happened this last week. I mean, obviously, everyone internationally is excited about SpaceX. But yeah, that's all I have for that. Latest in tech. Do you want to give a brief rundown?
Yeah, quick,
on the PACE
just
satellite?
some quick news for latest in tech on the PACE program. I briefly mentioned the PACE program on a previous episode, if you recall, with when President Trump released his proposed budget, saying that he was going to cut 4 Earth Sciences program. One of them was the actual PACE program. Obviously, the proposed budget from the White House is just a proposed budget, and we will see. I'm assuming we will see some semblance of a budget over the next couple of years from the Congress, but the White House's budget doesn't always reflect exactly what the budget what the budget Congress will pass.
They usually just take the president's budget, say thanks but no thanks, and throw it in the trash and start anew. And that's the story I've been hearing from folks on the Hill, and even people on the Republican side, like John Culbertson from Texas, the big Europa supporter. There was some big Europa stuff in this last week, but we can talk about that. Message me offline if you want to talk about Europa. But Culbertson was talking about how they're moving forward with the appropriations process for FY 2017 and 2018. They're going to get working on that as soon as possible. But back to PACE.
But on to PACE. So PACE is the Plankton Aerosol Cloud Ocean Ecosystem mission from NASA. And this past week, the PACE development team at Goddard just passed Key Decision Point B. Effectively, a design review is done to pass key decision point B to determine whether the proposed system architecture is credible and responsive to program requirements and constraints, including resources, which are typically a part of the requirements. The goal, quite frankly, is to reduce risk. That's the goal of having this decision point. And in the spirit of openness, NASA has even posted the steps that were required to get to Key Decision Point B as a workflow on their website. Now, for those of you who aren't typically into system design or software design, and in this case, it's system design because it's both hardware. It's a significant amount of hardware and software. Typically, there's a process. There's some process flow, and this can vary to some extent whether or not you do it in spiral or as one large series of steps. But effectively, you gather requirements, which is the first step, which was the first step of PACE, which is what they've been doing for the last, I want to say, 12 to 18 months. They had trade studies before that. And they actually planned this out in the last decadal survey, but effectively you gather your requirements, then you do a design plan in which you create your system, you propose a system architecture and a full-on approach to development such that it can be handed off to engineers and scientists to fully develop the actual system. At NASA, a critical design review is typically held once your design is completed for a particular system, and that seems to be what this Key Decision Point B was. So effectively, the PACE system has passed that point, and now they can go on to actual implementation of the capability. And this is all supposing that this entire program doesn't get cut. The PACE program overall, its goal is to provide systematic observations and continuity for ongoing ocean color research, systematic observations of aerosol and clouds in the climate record, and enhance ocean color remote sensing over a broad spectrum. The long-term record of observations of advanced ocean biology, ecology, biogeochemistry it will all directly benefit society by monitoring the extent and impacts of climate change.
You said climate change again.
I know.
I got flashbacks to our earlier discussion.
It's an extensive Earth sciences climate change capability, 100% necessary. Its notional launch date is in the 2022 to 2023 timeframe. It doesn't have a specific launch date just yet, and it's going to have a minimum mission duration of 3 years. But yeah, it passed Key Decision Point. It's being developed. Let's hope it keeps getting funded.
Yeah, let's hope.
So
the final section, we are running well over an hour at this point. So let's try to keep this between 5 and 7 minutes, if we can. Try to stop at about hour 15. So we have our final segment, I guess, is the listener submitted queries. Just discussion about a topic that one of our listeners submitted. So this one comes from Ben Johnson at The Ohio State University.
The Ohio State University.
The Ohio State, go blue.
Oh, whatever.
I had to throw that in there.
I'm from Ohio, ladies and gentlemen.
Well, I'm from Michigan.
We know. We can tell.
Talk to the hand. I'm raising my hand in a mitten form, a mitten to symbolize.
We're just kidding. This is a space podcast. We know nothing about sports, nothing whatsoever.
I know they exist. We might need to build some remote sensing satellites so we can gather more data.
And that the Ohio State University and Michigan are sworn enemies. Those are the only two things about sports that I know. All right, go on.
So Ben, my former roommate, a really good friend of mine, asks, what are the biological obstacles and challenges to human exploration of space? It's a really good question, and it's not something that I feel like we talk about a lot, or anybody talks about. I mean, people talk almost conceptually, almost as like human exploration of space as an abstract thing, as we'll do it in the future, but we have to develop our architectures and technologies now. A lot of those technologies that we need to be developing are for the medical application in space. I mean, people will be up there for extended periods of time. I mean, upwards of a year to 3 years on some mission architectures to Mars, beyond.
Right. Mars is certainly going to be, 2.5 years? So
it very well. Because we're not going to pull an Apollo and only be on the surface for 3 days. I mean, this is
you're going to be there for a year.
We're making very big commitments sending people there. So what are some of the biological obstacles and challenges? I think we talked a little bit about this a few weeks ago when we talked about Scott Kelly, who was up in space for a year, some of the effects that he has seen, and they're still undergoing tests, him and his twin brother, who also has been to space, Mark, sort of talking about their what's different from that 1 year, just 1 year in low Earth orbit.
Right. Well, and what's interesting, that not a lot of folks think about, a lot of folks are thinking about the radiation problem, which is, that's a massive problem, right? So much radiation exposure. And we really don't have technologies that can address that problem just yet. I think a lot of the public tends to think that problem is solved or is easily solvable. We really don't have anything to solve that issue right now. The other thing that often gets talked about is issues with bone density. There are actual well-known eye issues that can occur, blood filling up in certain pockets of the eye or in the brain because of the lack of gravity and the distortion of blood flow that comes from the lack of gravity in space. What's funny is it's funny that this question was actually brought up. I was at a lecture last Wednesday by Dr. Vince Machad he's the Deputy Chief Health and Medical Officer at NASA. He went to Georgetown to give a lecture that I was invited to. And one thing that he brought up that was interesting was how do we effectively rate or rank the level of medical aid for certain injuries that we can address in space. So if an astronaut lands on Mars and, for instance, someone breaks their leg, do we carry enough supplies? Do we have effectively surgery tables or surgery mechanisms that will enable us to perform surgery on Mars, or do we effectively set them up with a stint, right? And just kind of have them limping around for a year? We can only carry so many medical supplies with us on that mission, as well as medical expertise on that mission. Assuredly, there will be a doctor or a couple of doctors with differing specialities on that mission, but there's no one doctor who's going to be able to solve any problem that can occur with the human body. So that's really what makes this challenging. And one thing that I actually brought up to him is the benefit of having this problem, because I believe over the next couple of decades, as we are on our way to this mission, what we're going to see because of, quite frankly, the mission's need, are a series of lightweight technologies, or technologies even generated using materials and tools that come from 3D printing, that will allow us to address specific medical issues as we're on the mission to Mars, but we'll be able to adapt those technologies to help us out here on Earth as well. So I think we're going to see a significant number of spin-offs coming out of our search for addressing a large number of human biological issues, particularly injuries and maybe even some disease issues off planet. I think we're going to see a large number of spin-offs coming out of that for the next.
Oh, I mean, absolutely. I mean, during the height of the space race, I mean, a lot of the modern technology that we take for almost for granted in the medical field today can trace its roots back to the space program. Because I mean, what do they, when you're in space, you want everything that you have to be as efficient as possible, as cost effective as possible, and as small as possible. And all of those things were sort of the lens that scientists and engineers viewed technologies that they had to develop. And then, once we're done on the moon or done in low Earth orbit, those technologies transfer right over to the private sector and can help revolutionize sectors of the entirety of the healthcare world. I mean, but there are some significant challenges to being in space. One of the things I linked in the show notes a article on The Verge about Scott Kelly, some of the transformation his body has overcome, and even if you're just on the ISS for 6 months like a normal crew member, you have to get about 2.5 hours of exercise every day in order to counteract the atrophying of your muscles that is a direct result of being in a microgravity situation.
It's to address bone density as well, by the way.
And bone density.
Yeah.
Another thing is fluids. Blood, which tends to be fairly evenly distributed throughout your body in a normal gravitational environment, like on the Earth, can start to become. This article quotes it as being lazy, not pumping through your entire body, or what this article is saying is staying sort of towards the upper body, closer to the heart, so that it won't go as far, so your extremities don't get the same amount of blood as they would on the surface. And how to counteract that is sort of an issue that they're going to have to address, whether that's some new technology they're going to have to develop, or if the answer is,
Make gravity.
Make gravity, or eat more iron during your stay up in space, or do more exercise. We're not entirely sure. I mean, the ISS, of course, is going to help us, answer some of those questions, as well as the Deep Space Gateway. Something I wanted to bring up as sort of I know we talked about this separately, but the sort of the psychological aspect of it. Like psychological health is a major problem in space, and although that might not seem as if it's a physiological health problem, it can manifest itself as one. I mean, if you're cooped up in this tin can for 3 years or 2 years or whatever it ends up being, you can develop depression, you can develop anxiety disorders, you can develop these mental problems and obstacles, challenges that then can influence your day-to-day exercise regimen, can influence your dietary habits, and that can then impact your physical health. And sort of dealing with those, doing full psychological evaluations on astronauts, but also, you can't find someone who isn't going to be affected by some sort of, being in a contained area for 3 years. You're not going to find someone who can get out of that and be completely fine mentally, finding countermeasures to when problems like depression or anxiety can manifest themselves within your astronaut corps is going to be vitally important to getting to Mars without crew members ripping each other's heads off.
Also an area where there will be a significant number of spin-offs, because there's not really many other many other scenarios in which one has to research someone being secluded with 6 or 7 people for 2 years in a place where there's no communication. No, I mean, even in the military, you have more people than that. Even it can get quite lonely being on a base, being on a base in the middle of effectively nowhere. But this is a completely different scenario. You're off world, no communication. I keep going back to the Mars mission because eyes on the prize, but um, it's this is a scenario that humans. I won't say humans have never had to face this before, because effectively they had this when they came to the new world to some extent. But this is in an age where people are used to communicating with each other on on a day-to-day basis at all times. Even when you're alone, you can communicate. I'm alone in my room and communicating with you right now, Jack. Like, people are used to having constant communication with each other. And whoever the next class of astronauts are going to be to take on that mission are going to be used to that lifestyle. And taking that away would affect anyone that's used to that lifestyle.
So you have to, I mean, so the Hera mission is one that we've talked about out in Hawaii, correct?
Yes, out in Hawaii.
It's basically a facility where they simulate being in a contained environment like that for a couple months. I think the longest they've done is a 6-month stint in there in the brig. But you're out in Hawaii, but you're in a contained area that's about the size of what the deep space transport's going to be, with 3 other people. It's you and 3 other people, and with simulated communication delays with ground control, with all the amenities that you would have, as few as they are, and scientists and researchers are studying what this impact of a contained environment like that for only 4 people can do to their psychology.
Right. Yeah, absolutely. And it's something that obviously we're going to have to continue to study from now on. They're going to be running continuous studies of that Hera mission. This is NASA's Hera mission. It's a mission where you're set up with a habitat out in either Arizona or Hawaii. It's one of the two. Actually, it's both.
I would prefer Hawaii.
Yeah, yeah. It's actually they've tried it in both of them, I believe. But yeah, like I said, we should see a significant number of research findings for mental health, which I think, God forbid we don't have a Mars mission, that would still be a benefit to this kind of study, this kind of from this kind of mission. So yeah.
So Ben, I hope we answered your question to some extent. I know we kind of went off on a tangent, talking about the psychology, which your question was a bit more about biology. Included in the show notes are going to be some articles. There's an article. Newton, I want you to answer this question with a one word answer. Do we have to alter our DNA to go to Mars?
No. Next
okay.
question.
So, but you can read that article anyway, because it is an interesting idea. Another article is from Airspace Magazine, talking about potentially using hibernation, which is sort of, if you think back to the movie Interstellar, that's how they got to Saturn, or wherever the black hole or wormhole was. They used hibernation as a tool to counteract some of the physiological challenges.
Also, would be great for spin-offs here on Earth.
Oh, totally.
Are you kidding me? I would do it every day.
just go into hibernation every night.
8 hours a night, guaranteed.
Yeah. I'm going to include a link to the NASA biology program, the HERA program, and that article from The Verge talking about the effects on Scott Kelly. So Ben and all of our listeners who are interested in space medicine, there's some good articles there. Ben, I know you have some articles. Feel free to send those over and we'll promote. But I think we are running up almost on an hour and a half.
Yep. We are out of time.
we are almost 30 minutes over schedule. 25 minutes, I think, is what we're at now, over schedule. So I think we're going to sign off there. Next week, we're going to be talking about what we heard from the 33rd Space Symposium. And we have a question from our friend, Joanne Pierce. So stay tuned for that. That'll be episode 7. Can you believe it, Newton? Episode 7.
Episode 7. We've done 7 of these? My God.
7. I mean, we've done more than that, but no one's going to hear the
7
pilots.
that they'll know about. We don't
7
have
that they know about.
We don't have leaks here, all right?
We're not the White House.
And on that note.
All right. I'm Jack.
And I'm Newton.
Ad Astra.